Good morning to one and all. Welcome to the channel Firjan. Today we discuss electric charges and electric fields. 12th standard first lesson. In this one, 13th video, electric field due to charged spheres. Due to charged spheres, what is the electric field? That we want to find out. For that, first we discuss spheres. Spheres are two types here. See, one is hollow spheres or thin cells. Thin cells. Second one is solid spheres. See one, spheres are we have two types, hollow spheres, thin cells, or second one solid spheres. Here see, in hollow spheres, one is conducting hollow spheres, another one is non-conducting hollow spheres. Here solid na we have conducting and non-conducting. Conducting and non-conducting. Non-conducting we call it as dielectric, or we call it as insulators. Insulators. Here also same. Conductors are nothing but non-conducting, nothing but dielectric or insulators. See here, we have spheres two types, hollow spheres, solid spheres. Hollow is nothing but thin cells. See, conducting, non-conducting. Non-conducting is nothing but dielectric or insulator. Solids na conducting, non-conducting. Non-conducting is dielectric or insulators. See in this one, see here, except non-conducting solid sphere, non-conducting solid sphere rest of have same property. See here, except non-conducting solid sphere, rest of have same property. Rest of have means hollow, conducting, non-conducting, or non-conducting. Another one are solid conducting sphere. See here, except non-conducting solid sphere, rest of have same property. What are rest of have na? Hollow, conducting, non-conducting, or solid conducting sphere. What is the this have property na? Charge resides on surface of sphere. Charge resides on surface of sphere. See here, hollow, solid conducting spheres, charge will be resides on surface of sphere. Charge is resides on surface of sphere. See here, spheres hollow, solid, conducting, non-conducting, conducting, non-conducting. In this one, except non-conducting solid sphere, rest of have same property. Hollow means conducting or non-conducting or solid conducting. These have charge, total charge will be resides on surface of the sphere, not inside. See, for non-conducting, charge will be whole sphere, distributed whole sphere. Charge is distributed in whole sphere. Whole sphere charge is distributed. So these are the spheres, hollow, solid. spheres. In this one, first we discuss electric field due to hollow conducting non conducting or solid conducting sphere. See here, first we discuss electric field. Electric field due to hollow. Hollow means again conducting or non conducting. Another one is solid conducting. Solid conducting sphere. Solid conducting sphere. See, electric field due to hollow conducting non conducting or solid conducting sphere. This we discuss first here. See, in this one we can take solid sphere. So, or hollow all will be charges resides on surface of sphere. All are same property. This hollow conducting, non conducting, solid conducting spheres have same property. For that, see, for example, this is the sphere. It is either a hollow conducting or non conducting, solid conducting sphere. See, in this one, charge will be resides on surface of sphere. Charge is resides on surface of sphere. See, total charge is resides on surface of sphere. See, this is the charge resides on surface of sphere. Here what we can do now, it has, what is the charge now? Sigma. Sigma means here surface charge density. Surface charge density. What is the surface charge density now? Sigma equal to Q by area. Means surface charge density is defined as charge per unit area is called as surface charge density. Here charge is Q by A. Sigma equal to Q by A. In this one, what we can do now first here, see, we can, this radius is capital R, radius of the sphere is capital R. So, from center or distance from outside the sphere, this point, we can draw the Gaussian surface. This radius is smaller. This radius is smaller. See this point, what is the electric field? Means here we can draw first Gaussian surface. See, this is the Gaussian surface. Here see, this is the Gaussian surface. See first what we can do now here, see, this is the hollow or conducting or non conducting or solid conducting sphere. In this one, charge is sigma equal to Q by A, total charge per unit area. Charge per unit area is called surface charge density. Whatever the charge in this one hollow conducting or non conducting or solid conducting sphere, charge will be resides on surface of the sphere. For this, radius is capital R. See, all distance from the center outside the sphere, we can draw the Gaussian surface. Why we are drawing Gaussian surface now? We want to find what is the electric field at all distance from the center. For that we can draw the Gaussian surface. What is the Gaussian surface now here? Gaussian surface should be symmetric about charge distribution. Charge or charge distribution. So charge will be distributed symmetrically. See here, in this Gaussian surface, every point electric field is same. Means electric field must be symmetric at all points of the Gaussian surface according to Gauss law. See another one. On this Gaussian surface, theta is same at every point. It is either 0 or 90. 0 or 90. See, this Gaussian surface should not pass us through point charge. These are the properties of Gauss law. See, in this one we can draw the Gaussian surface. In this Gaussian surface, what is the flux passes through this Gaussian surface? That we find out. For that, what we can do now, see small area we can select here. In this Gaussian surface, we can select small area. This is area. So area vector, only outward normal can be considered as area vector for closed surfaces. That's why it is the area vector for this small area. So means we can select in this Gaussian surface small area, that is this one. So that is dA. For this we can draw the area vector. Area vector means only outward normal can be considered as area vector. This is the area vector. We can select here one more area. See, this one has area vector. It is outward normal. Here we can select small area. This one is outward normal area vector. This one we can select area, small area dA, outward normal. See here, plus charge means charge is resides on surface of the sphere due to hollow conducting or non-conducting or solid conducting sphere. This total charge is sigma equal to q by A. See, this due to charge, electric field is there. This electric field is always radial, but here positive charge is radially outwards, negative na radially inwards. Here positive charge na radially outwards. See the electric field, this point, this is the electric field. See, this is the electric field. So this means along the area vector. Here electric field, this is the electric field due to this charge, positive charge radially outwards. See this one, so radially outwards. See this one radially outwards. See, this is electric field. Here see, from center it is the electric field. See, radially outwards. Here this point, this area, electric field is radially outwards. See here, electric field and area vector along the same line. So means these two are parallel to each other. What is the angle between these two? Theta equal to angle between electric field vector and area vector. Here both are parallel now. What is the theta here? 0. Here also 0. Why? Because both are parallel. Here also 0. Here 0. Means angle between area vector and electric field vector 0. What is the flux through this one? For that, so this area d pi flux, 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 means total this Gaussian surface, this type of d pi is many is there, d pi, d pi, d pi, d pi, all we can add now. We can write pi total flux equal to integral E dot dA, E dot dA, electric field vector dot area vector, integral. We can take small added, so all small, now we can take integration, integral E dot dA. E means here electric field vector, dA means area vector. See here, E dot dA, see we can write E dA cos theta, we can remove dot product na, E dA cos theta. What is the theta value here? 0. Here also theta equal to 0, here 0. So here also 0, means everywhere theta value same. So that's why we can write here integral E dA cos 0. Cos 0 means 1. See, integral E dA we can write. What is the flux through this Gaussian surface na? Pi equal to integral E dA. See here, electric field. According to Gauss law, electric field at every point on the Gaussian surface is symmetric. Symmetric means same or equal or constant. Means in this Gaussian surface, every point electric field is same. So that's why we can write electric field. We can write outside integral dA. So integral dA means this area vector, all area vectors added. Added means we can get total area. So that is EA. So pi equal to EA. A means here area of the sphere. What is the surface area of the sphere? Pi equal to E. Area of the sphere means 4 pi r square. Here smaller. See here this radius is smaller. So 4 pi r square. Flux through this Gaussian surface is E into 4 pi r square. E into 4 pi r square. Now see, according to Gauss law, this we can take one. See, according to Gauss law, now what is the flux? Gauss law means the net flux passes through closed surface is 1 by epsilon naught times net charge enclosed by the closed surface. Net charge enclosed by the surface. So that means pi equal to Q inside by epsilon naught. Q inside by epsilon naught. See here, here pi, here pi. So these two equate now. Before that we can write what is the charge here in this one. See, charge is Q, capital Q is there. Q inside means we can write capital Q. So that capital Q here we can write, see, sigma equal to Q by A. Sigma equal to capital Q by A. From that Q equal to sigma into A. Sigma into A. Instead of here Q, we can write sigma into A by epsilon naught. A means surface of the sphere. Surface of the sphere means here 4 pi r square. So pi equal to sigma 4 pi capital R square by epsilon naught. This we can take to, see here phi. So mathematically flux through Gaussian surface is E 4 pi r square. According to Gauss law, pi equal to what? Sigma 4 pi r square by epsilon naught. Sigma 4 pi r square by epsilon naught. These two from 1 and 2. I write here from 1 and 2. See for what now 1 pi, here also pi. So we can write E 4 pi r square equal to sigma 4 pi r square by epsilon naught. See, this 4 pi cancel. What we can write? E electric field equal to sigma capital R square by epsilon naught small r square. This is the electric field due to this solid conducting or hollow conducting non-conducting sphere. See, due to this sphere, what is the electric field now? Sigma r square by capital R square by epsilon naught small r square. Epsilon naught small r square. So that is the electric field due to that solid conducting or hollow conducting or non-conducting sphere. So sigma E equal to sigma r square by epsilon naught r square. From this what we can write? Electric field is directly proportional to, sorry, electric field is proportional to 1 by r square, means inversely proportional to square of the radius. Inversely proportional to square of the radius. This all will be outside the sphere. What is the electric field? Outside the sphere at all distance from the center. So that is E proportional to 1 by r square. E proportional to 1 by r square. See here, instead of here sigma 4 pi r square, we can write capital Q. Why not? Charge is, total charge is here Q. We can write, see, E equal to, instead of this 4 pi r square, we can write sigma 4 pi r square, we can write capital Q. What we get now here? See, 1 minute. See, I write here, here. Instead of this, I write here, or we can write Q by epsilon naught. Q by epsilon naught. See, from this, here pi, here phi. We can write, instead of pi, we can write Q by epsilon naught. See, E equal to E into 4 pi r square, that equal to Q by epsilon naught. Q means here total charge resides on the surface of the solid conducting or hollow conducting non-conducting sphere. So that is capital Q by epsilon naught. From that what we can write? E equal to electric field equal to Q by 4 pi epsilon naught r square. So this is another expression we are getting. Either this one or this one, both are correct. See here, here also E proportional to 1 by r square. This also same, electric field is inversely proportional to square of the radius. Yes na? So electric field outside the sphere or distance from the center. What is the electric field na? We can write E equal to sigma capital R square by epsilon naught small r square, or we can write electric field equal to capital Q by 4 pi epsilon naught r square. Either this one we can write or this one we can write. Both are correct only. So for this one we can take now. See here, what we can observe now here. This total charge will be act as Q. From the, we can see from far distance now, what this total solid sphere will be appears as Q. So means it seems as if Q is placed at center of sphere. Placed at the center of sphere. See here, it seems as if Q is placed at center of sphere outside the sphere. From outside sphere we can see it will be appears like outside the sphere. See, this total will be appears as Q at center. Due to this, what is the electric field now here at P, this point? So due to Q, electric field at small r distance now Q by 4 pi epsilon naught r square. 4 pi epsilon naught r square. So like this it will appear. Means it will be act as Q point charge at center. See, what is the electric field due to hollow conducting or non-conducting or solid conducting, all are same. Why now? Charge will be resides on surface of the sphere. Total charge will be resides on surface of the sphere. That's why this all cases we can take one case. So that is, this is the charge on resides on surface of sphere. Here what we can do now, this radius is r, or distance from the center, we can draw a Gaussian surface. For this Gaussian surface, what is the flux passes through this Gaussian surface? We find out that is pi equal to integral E dot dA. E dot dA means E dA cos theta. What is the theta value here? 0. Instead of cos, we can write 0. Cos 0 means 1. E dA we get E outside. Why? Because electric field is same on the Gaussian surface at every point. So constant integral dA. A means here surface area of this Gaussian surface. What is that? 4 pi r square. E into 4 pi r square. See, according to Gauss law, the net flux passes through the closed surface is 1 by epsilon naught times net charge enclosed surface. Means pi equal to Q inside by epsilon naught according to Gauss. See, Q equal to pi equal to Q inside means, see, actually sigma equal to Q by A. So Q means sigma A. Instead of here Q inside A, Q inside sigma A we can write by epsilon naught. This two pi same. This equal to this means what we can write now here? He 4 pi r square equal to sigma. A means here area of sphere. So means 4 pi capital R square. This 4 pi cancel. E equal to sigma r square by epsilon naught r square. This is electric field due to conducting solid sphere or hollow conducting non-conducting sphere. So or we can write it as this one, E equal to Q by 4 pi epsilon naught r square also. Both are correct. See, now inside the sphere, what it is we can discuss. Inside sphere, see, this is electric field due to outside the sphere. What is the outside the sphere? E proportional to 1 by r square. So inside sphere we can write, see, this is the sphere, charge will be resides on surface of sphere. See, inside sphere, this capital R is radius of the sphere. Inside sphere, a small r distance from the center, we can draw the Gaussian surface. This is distance is smaller. From this distance, here, this is the Gaussian surface. Smaller distance inside the sphere, we can draw the Gaussian surface. This is the Gaussian surface. Means inside sphere. Before we discuss outside sphere. Inside point now. At this point, what is the electric field? That we find out. See here, r distance from the center. See, this one we can draw the area vector dA. Electric field outward. Yes, na? See, we can write what is the flux through this Gaussian surface? Pi equal to integral E dot dA. Here, electric field vector and area vector both are in same direction. So means parallel to each other. That's why theta equal to 0. We can write here integral E dA cos 0. Cos 0 means 1. See, we can write E is same. So we can write dA. So means E dA means A. So means pi equal to what here? E surface of this Gaussian surface of surface area now. Here we can write 4 pi small r square. So pi equal to 4 pi r square. See, according to Gauss law, see what the net flux through the closed surface is q by epsilon naught times net charge enclosed by the surface, means 1 by epsilon naught times net charge enclosed by the surface. So that's why pi closed equal to q by epsilon naught, means q here means inside. What is the charge inside this Gaussian surface? No charge, so means 0. So means here what we can write? 0 we can write. See here, this one pi equal to e 4 pi r square, here pi equal to q inside by epsilon naught, both equate. Now here we can write e 4 pi r square equal to q inside by epsilon naught. Q inside is what? 0. So means e 4 pi r square equal to 0. So means e equal to 0 by 4 pi r square. See, e equal to what we get now? 0. Means electric field due to hollow conducting or non-conducting, a solid conducting sphere inside or distance from the center. What is the electric field now? 0. Electric field inside hollow conducting or non-conducting solid conducting spheres is 0. Outside point, this is the electric field. So electric field is sigma r square by epsilon naught r square, means what is the relation? Sigma is proportional to 1 by r square. So inside sphere 0. We can find now on surface. On surface of sphere, what is the electric field? So that is here e 4 pi capital R square, that equal to q inside by epsilon naught. Why we can write now directly here? See this one on surface now, this only Gaussian surface. So mean that case, what now flux through surface is pi equal to e dot dA, integral e dot dA. So pi equal to, that equal to q inside by epsilon naught, charge inside by epsilon naught. E dot dA means e, integral dA means 4 pi small capital R square, that equal to q inside by epsilon naught. See, E equal to q inside by 4 pi epsilon naught capital R square. This is the electric field due to hollow conducting or non-conducting or solid conducting on surface. On surface. This is on surface, inside or distance from the center. Outside now, see electric field, what now we can get? Q by 4 pi epsilon naught small r square we are getting, before we discussed. See, that means E proportional to 1 by r square. See, for this all we can draw the graph. For that, see, for example here on x axis distance we can take, y axis we can take electric field. Electric field, see electric field due to this sphere inside or distance from center is 0. On surface 1 by r, so 1 q by 4 pi epsilon naught capital R square, capital R square. Outside surface, this is outside surface, outside surface or distance from the center. So that is E equal to q by 4 pi epsilon naught small r square. See this case here, see this is the conducting sphere, solid conducting sphere or hollow conducting non-conducting sphere. See, inside the sphere means or less than capital R, that distance electric field is 0. Electric field is 0. R equal to capital R, maximum. See, maximum. This is maximum. See, after that, what now? E proportional to 1 by R square, means radius increases, electric field decreases. This is the graph for, so means here E proportional to 1 by R square. Here E equal to 0. Here E equal to surface na maximum. Surface is maximum. See here, this is the graph for hollow conducting or non-conducting or solid conducting sphere. How electric field changes inside means or less than capital R, E 0, R equal to R maximum. Outside sphere Outsphere conducting solid sphere, E proportional to 1 by R square, means electric field is decreases. So this is the graph for electric field versus radius. Electric field versus radius for hollow conducting, non-conducting or solid conducting sphere. Yes, na? So now we discuss electric field due to non-conducting sphere. Electric field due to non-conducting sphere. In non-conducting sphere, charge will be distributed uniformly inside the sphere, means whole sphere. See right here, electric field due to non-conducting solid sphere. Non-conducting solid sphere. See here, this is the non-conducting solid sphere. Before charge is for hollow conducting or non-conducting solid conducting sphere, total charge will be resides on surface of the sphere. But in non-conducting sphere, charge is whole sphere, not surface. Whole sphere is there. See, this is the charge. Inside the sphere is there. This total charge is distributed the whole sphere. This case, this radius is capital R. Radius is capital R. See, for this R distance from outside point, this point, we can draw first Gaussian surface. This one, R distance from the center. R distance from the center, we can draw the Gaussian surface outside. In this one, what is the flux passes through this Gaussian surface? We can find out later. What is the electric field, we find out what is the relation between electric field and radius. First, see here, electric field due to non-conducting solid sphere. Non-conducting solid sphere, total charge will be distributed whole sphere. Before, only charge will be resides on surface of sphere for solid conducting and hollow conducting or non-conducting. For this one, charge will be distributed whole sphere. This case, this radius is capital R. R distance from outside the point. First, we can write here outside point. See here, here we can write volume charge density. See here, volume charge density means rho. Rho equal to what now here? Charge per unit volume. Charge per unit volume means volume charge density. Rho means volume charge density. Charge per unit volume. So means here Q equal to what we can write? Rho V. Rho V. See outside sphere. Here we can draw the Gaussian surface outside sphere. Outside sphere means R is greater than capital R. That case, this is the Gaussian surface. For this, what we can do now? First here, we can draw the, means we can take for small area. Area we can draw area vector, CDA. Area vector means outward normal can be considered as area vector for closed surface. This is the area vector. This point, we can draw the area vector. This is area vector. This point, this is the area vector. This point, this is the area vector. See here, this is outward normals. Outward normals. This is the outward normal. This is outward normal. Outward normal. See, due to this plus charge, means electric field is radially outwards. So radially outwards means this one. See electric field here. This area electric field is E along the area vector. Here electric field. Here electric field. This is the electric field direction. See here, electric field and area vector both are in same direction. Means what is the angle between electric field and area vector? Here 0. Here also area vector and electric field is 0. Theta is the angle between area vector and electric field. This is here is 0. Here also 0. See, we can write flux through Gaussian surface. This Gaussian surface, that we can write total flux. This d pi na, this area na d pi flux, this area d pi flux, this area d pi flux, this area d pi flux. This total flux d pi is added. Now we get pi equal to integral d pi, that equal to integral e dot dA. E dot dA. Here see pi equal to integral e dot dA means e dA cos theta. Here theta value is what? 0. So pi equal to integral e dA cos 0 we can write. Cos 0 means 1. So pi equal to integral e dA we can write. E is electric field is same, symmetric at every point on the Gaussian surface. So that's why we can write outside E integral dA. Integral dA. See here E integral dA means A. What now here see this surface area we can write. See here what is the surface area? Pi equal to E. Surface area of this Gaussian surface means Gaussian sphere is 4 pi small r square. According to Gauss law, what is Gauss law? Net charge means total flux passes through closed surface is 1 by epsilon naught times net charge enclosed by the surface. Means total flux passes through closed surface equal to q inside by epsilon naught. Q inside by epsilon naught. See flux. Q inside means here this total means C is there. So means total volume means density equal to what? Q by V. So means Q equal to rho V. Rho V. I write here instead of Q inside we can write pi equal to rho V by epsilon naught. See here rho means density. Volume means 4 by 3 pi capital R square. Why not here this one capital R radius? That's why rho 4 by 3 pi R square by epsilon naught. What is the charge inside the this sphere now? See Gaussian surface now sigma 4 by 3 pi R square by epsilon naught. This pi same. So means this equal means electric field into 4 pi R square equal to rho 4 by 3 pi capital R square by epsilon naught. See here this 4 pi cancel. What we get now here? E equal to electric field equal to rho capital R square by 3 epsilon naught small r square. From that what we can write? See electric field is proportional to 1 by r square. It is for outside the solid non-conducting sphere. Electric field due to this solid non-conducting sphere or distance from center of the solid non-conducting sphere outside the sphere. Outside the sphere. What is that now? Actual electric field equal to rho r square by 3 epsilon naught r square. From that what is the relation? Now electric field is proportional to 1 by r square. Inside sphere we can write. Here inside first one we can write on surface we can write surface on surface now. See on surface what now here see here electric field now E into 4 pi r square, flux is E into 4 pi r square. See here this one this surface flux is E into 4 pi capital R square, 4 pi capital R square. So from that we can write here flux through this surface means on surface what is the flux through this on surface now? See E into 4 pi capital R square, capital R square. See in this case according to Gauss law, what is the Gauss law? Net electric flux through closed surface is 1 by epsilon naught times Q net charge enclosed by the surface. Means here flux equal to what we can write according to Gauss law? So pi equal to Q inside by epsilon naught. This pi equal what we can write here? E 4 pi capital R square equal to Q by epsilon naught. See here E equal to what we can write? Q by 4 pi epsilon naught R square. This is the electric field on surface of the solid non-conducting sphere. Outside the sphere na E equal to rho r capital R square by 3 epsilon naught small r square. On surface na E equal to Q by 4 pi epsilon naught capital R square. Now see inside the sphere, inside conducting sphere, non-conducting solid sphere, we can find out. See for example here, see this is the conducting sphere, sorry, non-conducting solid sphere. Charge will be distributed whole sphere. Here see, whole sphere charge is conducted, distributed. In this one, this area is capital R. This area is capital R. Here, smaller distance, from center or distance, we can draw the Gaussian surface. See Gaussian surface. This is the Gaussian surface. This is the Gaussian surface. Or distance from center, or distance from center. See here we can draw the, means we can take small area, means what now, this is the area vector. See, due to this charge electric field is this only E, so both are in same direction. What is the flux through this area? So means d pi integral E dA we can write. E electric field vector dot dA vector. What is the angle between them here? Theta equal to E and D are in same direction, means parallel to each other. So theta equal to 0. That case what we can write here? So d pi equal to integral E dA cos 0. So means what we can write, d pi equal to integral E dA we can get. See here this type of d pi, here 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 d pi, means what we can take integration. So what we can get here, phi equal to integral E dot E dA, integral E dA. See one more here, small, due to this area, what is the flux na? Here no need integration, sorry. See here, due to this small area, what is the flux na? D pi equal to E dot dA. Here also no need integration. See E dot dA, that we can write E dA cos theta. So theta value is at what here, 0, E dA cos 0. See here we can get d pi equal to E dA we can get. See this type of electric flux is d pi is here, 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 all Gaussian surface, total surface is there. So when this all d pi is added na, we can take integration. Integration. D pi means pi. So pi equal to integral E dA. Here E means electric field is same every point on the Gaussian surface. So we can write outside CE dA. A means integral dA means A we can get. This is inside the surface. Inside surface. Inside surface we can draw Gaussian surface or distance from the center. In this one we can select small area. So area vector this one, electric field vector also same direction. In this one area vector this one, electric field vector this one. So this area we can select area vector and electric field vector, both are in same direction. See area vector, electric field vector. So means what is the flux? D pi equal to E dot dA. E dot dA na E dA cos theta. So d pi equal to E dA cos theta. What is the angle? Theta equal to here 0. So we can write E dA we can write. See this d pi is all added na, integral we can take. Integral d pi equal to integral E dA. So d pi na pi. So means E is constant. So we can write outside integral dA. dA means A. So means pi equal to what here? E A. So pi equal to E. A means this surface. What is the surface area? So 4 pi small r square. 4 pi small r square. Now see here, according to Gauss law, flux through closed surface equal to Q inside by epsilon naught. Q inside by epsilon naught. So pi means total flux through closed surface is 1 by epsilon naught times net charge enclosed by the surface. Net charge enclosed by the surface. See here in this surface, in this Gaussian surface, what is the net charge? That we want to find out. For that, what we can do now here, see, actually rho equal to charge per unit volume. Rho equal to what? Charge per unit volume. See here, charge equal to what? rho v. Charge equal to what? Rho v. Rho means density of the volume charge density. Volume charge density. V means volume of the sphere. What is the volume of the sphere? Smaller distance. Volume means 4 by 3 pi r square. I write here pi closed equal to q inside na. So rho v we can write by epsilon naught. So rho v means 4 by 3 pi small r cube. 4 by 3 pi small r square epsilon naught. So what is the flux through this closed surface na? Rho 4 by 3 pi r cubed by epsilon naught. See here this pi equal. So we can write E 4 pi r square equal to rho 4 by 3 pi r cubed by epsilon naught. See here this 4 pi cancel. This r square cancel, one only we have. See I write here E equal to what we get now here E equal to rho r by 3 epsilon naught. Rho r by 3 epsilon naught we get here. See what is the electric field due to inside or distance from the center na E equal to rho small r by 3 epsilon naught. How now this one? See here once again, this is the inside Gaussian surface or distance from the center. For this Gaussian surface, what is the flux passes through this Gaussian surface? That we can find out. For that we can take area vector, small area dA, 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 here dA. So this electric field also radially outwards, due to this electric field radially outwards, radially outwards, radially outwards. This electric field and area vector both are parallel, so theta equal to 0. That's why I write here due to this area, what is the flux through? D pi E dot E dA. So d pi equal to E dA cos 0. Why not theta equal to 0 here? E dA we can get. This d pi, d pi, d pi all we can add. So we can take integration. Integral d pi equal to integral E dA. Integral d pi means pi. Integral E dA. E means here constant. Why? Because Gaussian surface. At every point on the Gaussian surface, electric field is symmetric. Symmetric means equal or constant. That's why we can write E outside. Integral dA. Integral dA na A. A. E means electric field. A means area of this Gaussian surface. What is the area? Radius is smaller. So 4 pi r square. Surface area is 4 pi r square. See now by using Gauss law, what na? So net flux through closed surface is 1 by epsilon naught times q inside. That only right. Flux through closed surface equal to q inside by epsilon naught. Q inside by closed, q inside now here what? Rho equal to qv, q by v means charge volume charge density equal to charge per unit volume. From that charge equal to rho v. Instead of q here rho v we can write. Rho v means here volume of this small sphere, means Gaussian sphere. So in this case radius is r. So 4 by 3 pi r cubed I write here pi. So pi equal to rho 4 by 3 pi r cube by epsilon naught. This pi equal. So this we can write E dot 4 pi r square equal to rho 4 by 3 pi r cube. Here 4 cancel, pi cancel, r cubed. Here r square is there, r square cancel, 1 is there. So means E equal to rho r by epsilon naught, 3 epsilon naught. E equal to rho r by 3 epsilon naught. This is the electric field due to solid non-conducting sphere or distance from the center inside the non-conducting sphere. This is the electric field on surface. This is the electric field. This is the electric field due to solid non-conducting sphere outside the sphere. Outside the sphere. These three we can write and draw the graph. See, I write here graph. See, this is the radius or this is electric field. See here, r less than capital R, r equal to capital R, r greater than capital R. These three cases. First, r less than R. See E. Or now what is the relation here? E proportional to small r. So means electric field inside the sphere or distance from the center. What? E proportional to R, directly proportional. Means here, for example, this is the sphere, solid non-conducting sphere. Means what here? Electric field is directly, means proportional to R, small r, directly proportional to small r, small r. So that's why electric field increases from center to towards surface. See here, at r equal to capital R, this case electric field is maximum, that is E equal to q by 4 pi epsilon naught capital R square. So that this is the maximum. See maximum, this one. See next here, see after that what is the electric field outside the sphere? Sigma r cubed by 3 epsilon naught r square, means E proportional to 1 by r square, means electric field decreases. See here, electric field decreases, means E proportional to 1 by r square. This is the electric field outside the non-conducting solid sphere. Non-conducting solid sphere. Inside is E proportional to r, on surface maximum, outside surface E proportional to 1 by r square. E proportional to 1 by r square. This is the graph for solid non-conducting sphere. Solid non-conducting sphere. Outside point, what is the electric field na? Rho r cubed by 3 epsilon naught r square. On surface na E equal to q by 4 pi epsilon naught r square. Inside surface, smaller distance from the center na E equal to rho r by 3 epsilon naught, means E proportional to r inside. Outside E proportional to 1 by r square. On surface maximum. On surface maximum. This is the graph for electric field due to non-conducting solid sphere. Non-conducting solid sphere. Next we discuss non-uniform solid sphere. Non-uniform solid sphere. This is the last one, electric field due to non-uniform solid sphere. See here, electric field due to non-uniform solid sphere. Non-uniform solid sphere. Here charge is how to distribute na rho naught small r. So means it is r increase na rho naught value changes, means not uniform. So means radius increases, this charge density changes. So non-uniformly distributed charge. See here, this one we can take. In this one, charge is non-uniformly distributed. This we can take. This radius is capital R. Radius is capital R. Non-uniform solid sphere. Charge density is, means volume charge density is rho equal to rho naught R. This case, what we can do now here, see smaller distance. See smaller distance from the center. We can write, so, means Gaussian surface. This is the Gaussian surface. See here, it is the radius of the sphere, non-uniform solid sphere. We can select r distance from the center, small r distance from the center. We can draw the Gaussian surface. So due to this, through this Gaussian surface, first we find out what is the flux passes through this one. See this one here, this point we can take. It means small area. See, it is outward normal. So electric field also outward normal. Electric field also outward normal. See what we can write, total flux. Why? Because this area means all we can add it. Finally, I find out total flux through this Gaussian surface. See pi equal to integral E dot dA we can write. Here area vector and electric field vector both are parallel to each other. So parallel to each other means theta equal to 0. I write here integral E dA cos 0. Cos 0 means 1. So integral E dA we can get. Electric field outside I write. E integral dA we can write. So dA means area of the Gaussian surface. What is the Gaussian surface area here? E into 4 pi small r square. So this is the flux through this Gaussian surface for non-uniform solid sphere. Now what is the charge inside the Gaussian surface? So according to Gauss law, what we can write? Flux through flux through flux through closed surface is flux through closed surface equal to q inside by epsilon naught. Q inside by epsilon naught. Here see, this is non uniform solid sphere. Q inside is radius increases, charge also changes. So charge value changes. For that, first we find out what is the charge inside. For that we can take here, actually I write here, see, charge density equal to charge per unit volume. Charge per unit volume. So Q equal to what here? Rho V means charge volume charge density rho equal to charge per unit volume. From that Q equal to rho V we can write. Q equal to rho V. For that, this we can take here. This is sphere. So means inside or distance from the center or smaller distance. This one is charge is there distributed non-uniformly. For this, how much charge is this sphere contains? Gaussian surface. This sphere means Gaussian sphere, Gaussian surface. What is the charge we can write? For that, what we can do now, from r distance, I take here, this is the Gaussian sphere inside the solid non-uniform solid sphere. See this one. See, for example, this is the sphere. This one, from center x distance, we can take small region, small elemental region we can take this one. So this contains charge. What charge now here? Dq charge it has. What is the charge? This one, dq charge, and this thickness is dx. What is the thickness of this sphere? Means cell na dx, and charge is dq. What na here? Total charge. So means dq equal to, we can write what? Dq, q equal to what? Actually rho v. Here dq na rho dv we can write. Rho dv. Why? Because small charge, small volume, small charge, small volume. So that's why we can write dq equal to rho dv. Here see, dq equal to rho means volume, so mean density. What na density here? See, actually density how na they gave? Volume charge density rho equal to rho naught r. Here we can write rho naught v na here, rho naught r na here, distance is what here? X. So rho naught x we can write. So rho naught x and dv means volume. See here, this will be cut and extended now, it will appears like this. See here, it will appears like this. This is charge is dq, this thickness is dx, this surface area is 4 pi r square, but here what distance? X. That's why 4 pi x square is the surface area and the thickness is dx. What is dv? Volume equal to surface area 4 pi x square into thickness dx. So we get area into length na volume. So we can get here dv equal to 4 pi x square dx we can write. See here, instead of dq equal to rho naught x, rho naught x dv na dv means what we can write? This value 4 pi x square dx. I write here 4 pi x square dx I write. See, dq equal to what we get? Rho naught x into 4 pi x square, 4 pi x cubed dx we can get. See, dq equal to, again I repeat, see, it is the actually solid non conducting, sorry, solid non-conducting, solid non-uniform sphere. Solid non-uniform sphere. In this one, I draw the Gaussian surface inside or distance from the center. In this Gaussian surface, what is the flux through this Gaussian surface? I find out. So electric field means electric field vector is outwards, area vector outwards. Both are parallel, theta equal to 0. That case total flux pi equal to integral E dot dA. Integral E dot dA means dA cos 0. E dA cos 0 means 1. So E dA we can write. E is outside, right? Why? Because electric field is symmetric at every point on the Gaussian surface. That's why E integral dA. dA means A. A means area. Area of the Gaussian surface is 4 pi. Radius is smaller, so 4 pi r square. E dot 4 pi r square. Pi value flux through this Gaussian surface is E dot 4 pi r square. Now see, according to Gauss law, what Gauss law? Net electric flux through closed surface is 1 by epsilon naught times charge inside the sphere, inside the sphere or inside the closed surface, that is q inside by epsilon naught. Pi closed, flux through closed surface equal to q inside by epsilon naught. Q inside na, for that actually volume equal to volume charge density equal to q by v. So from that q equal to what we can write? Rho v we can write. So that's why we can here write. See, density equal to volume charge density equal to q by v. So means q equal to rho v. But here see, this sphere means Gaussian sphere we can take. This is the Gaussian sphere. Radius is smaller. So in this case, what now we can take now here? It is non-uniform. That's why it will be x distance from the center. Small elemental part I cut. Why? Because charge is increases. Means volume charge density is changes. So means R value change na, volume charge density changes. That's why I first we find out, for take small elemental part na dq. dq equal to what? Actually q equal to rho v. So dq means rho dv. Why? Because small volume. See, for this it will cut extend na, it is this one. So this area is 4 pi x square. Why? Because x distance is there from center. So thickness is dx. So this is dq charge, dx thickness. That's why this will be cut and extended now. Like this will appear. It is surface area 4 pi x square. Thickness is dx. 4 pi x square into dx na volume we can get for this volume. So what now here? dv equal to 4 pi x square dx. We want here dq, rho dv, rho means rho naught x distance, x I write 4 pi x square dx dv value I write here. So x into 4 pi x square, rho naught 4 pi x cubed dx. dq equal to I write here, integrate, take both sides. So why? Because now, so like this here, from here to or distance we find out. For that what we can take the total. This is elemental part. This type of is there, many is there, infinite is there. That's why you can take integral dq, integral rho naught 4 pi x cubed dx we can take. Interval is 0 to r distance. So we can write here 0 to small r. So dq means here q equal to integral 0 to r, rho naught constant, or right outside 4 pi constant. So remaining what here? 0 to small r x cubed dx we can write. See, this one we can write here, q equal to rho naught 4 pi integral x cube means x power 4 by 4 into 0 to r. So what we can get now here? Q equal to rho naught 4 pi x means here instead of x we can write upper limit means r power 4 by 4. 0 we can write now, no 0 value. So that's why what is the q now here? Rho naught 4 pi r power 4 by 4. 4 cancel. What is the q value here? Rho naught pi r power 4. So means here what we can write now here? Q pi closed equal to q inside by epsilon naught. Here pi equal to what we get? E dot 4 pi r square. These two equate now. What we get? Pi, sorry, E 4 pi small r square equal to this pi closed equal to what? Q inside by epsilon r. Q inside is what? Rho naught 4 pi r power 4. I write here rho naught pi r power 4 by epsilon naught. See here, this pi cancel. See here, r cancel. What we get? An electric field equal to rho naught r square by 4 epsilon naught. This is the electric field due to non-uniform solid sphere, small r distance from the center inside the non-uniform solid sphere. Inside the non-uniform solid sphere means E equal to rho naught r square, small r square by 4 epsilon naught, means electric field is directly proportional to square of the radius from center to surface, center to surface. This is the electric field and radius relation for non-uniform solid sphere. Okay, this is the electric field due to charged spheres. Thank you.